They're the biggest storms on Earth. Hurricanes can last for days. They can cross entire oceans and bring devastation wherever they touch land. At their heart is an eerie zone of calm, the eye of the storm. They're fatally unpredictable. This film will take us into the heart of the hurricane, a storm on a global scale, truly built for destruction. This is some of the most ferocious weather the Earth can produce, the ultimate in storms. Hurricanes. They're killers. Hurricanes have destroyed thousands of homes with their devastating arsenal of weapons. Wind. Rain. And waves. They've taken hundreds of thousands of lives all around the world. The hurricane's weapons are awesome. Within the vast body of the storm are some of the fastest winds on Earth. In just a few days, a hurricane can produce a year's rainfall across a whole region, or bring a wall of water smashing in off the sea. We can do our best to resist them. But we may as well just turn and run. Because the power of the hurricane just keeps on coming. Each hurricane is different, an individual with its own name and its own characteristics. Each storm tells us more about what makes a hurricane, how it destroys, and what we can do about it. Hurricanes can flood vast regions, dominate oceans, blow away cities. How do they get this kind of power? How is a hurricane born? Hurricanes need energy, a source of heat to fuel their movement. And that heat comes from the warm oceans of the world. Hurricane-scale storms appear in the Atlantic, the Pacific, and the Indian Oceans. They usually form over water that's warmer than 79 degrees Fahrenheit, that's 26 degrees centigrade. A series of big thunderstorms gathers. They merge together and start to spin. The storm is organizing. Sea conditions worsen. Wave height builds. The wind speed picks up. When it hits 74 miles or 119 kilometers an hour, it's official. We're inside a hurricane. This is how it works. Warm seawater makes the air above it heat up and rise. More air rushes in from the sides to fill in the space. An updraft has been created. The mighty heart of the hurricane has started to pump. There are 5 levels of hurricane. A Category 1 will take down a few trees, but it's the big ones that do the serious damage. A Category 5, starting at 156 miles, that's 251 kilometers per hour, is devastating. It can obliterate entire cities. true hurricanes only happen in the Atlantic and Eastern Pacific. There are about 15 a year. In the Western Pacific, they're called typhoons, and cyclones virtually everywhere else. But they're all the same kind of massively powerful storm. They all share the same basic anatomy, and we can see it best from space. The outer region of storm clouds looks like a spiral galaxy. The storm gets more intense as we travel further inside until we hit the region of maximum devastation. This lies in a ring of cloud called the eye wall because it surrounds a black dot, the calm in the center of the hurricane, the eye itself. Let's see the strength of these storms. First, the awesome force of the wind. Hurricane Andrew was small but ferocious. Florida, August 1992. As millions evacuated, taking to the highway, Andrew approached. It was coming on like a bulldozer. Andrew was a Category 5. Miami lies like a bullseye on the tropical Florida coast. Andrew didn't even pause for breath before it took out the suburbs of the city. Andrew was a severe hurricane, one of the worst. It did more damage to the USA than any other storm in history, some $26 billion. More than 25,000 homes were destroyed. Andrew shows the power of hurricane force winds. Each part of Hurricane Andrew contained different kinds of wind, and they caused different kinds of damage. The structure of a hurricane may look orderly from here, but if you're down on the ground, it's chaotic. There are isolated gusts, which are much stronger than what's normally called hurricane force. And what that does to buildings can be surprising. The winds produce a pattern of streaks. One house or mobile home's gone, but its next-door neighbors are relatively unscathed. Let's go inside one of these gusts. Stanley Goldenberg, a meteorologist, found himself in the heart of one of Andrew's streaks.
You can start to hear the roar outside.
This is Stanley's dispatch from inside Hurricane Andrew and the home video he filmed at the time.
We can hear things start to fly around out there. I'm sure we're approaching hurricane force winds.
We were here during the worst part of the storm. We were first in the hallway, and then we tried to get to the garage, but it was already gone, so we ended up in the kitchen. While we were there, the whole roof had been ripped off of the house, flew over the fence, and smashed right into the neighbor's house. And I believe they were in it at the time.
This is what the neighborhood looked like the next day when Stanley crawled out into the open. His house was totally destroyed, but a few houses along, they're almost unscathed. It's a classic streaky wind pattern. This random destruction is terrifying, but it's not the worst a hurricane can do. The deeper you go, the more extreme the conditions. Almost at the heart of the storm, we hit the eye wall, a towering pillar of storm clouds reaching up 8 miles or 13 kilometers. The eye wall is the danger zone. Why does it get more intense closer to the center? It's a bit like an ice skater. The air entering a hurricane rotates. It has spin. As the air moves closer to the middle of the hurricane, it spins faster. It's like when the skater pulls her arms closer to her center. She turns faster. So in a hurricane, the spin at the eye wall is much faster than the spin further out. The eye wall is the area of ultimate destruction. To understand what that really means, we need to get down off our satellite and go to ground level, to meet a man who's actually been in the eye wall. Andrew's eye wall. This residential neighborhood south of downtown Miami felt the full force of Hurricane Andrew's assault on Florida. The eye wall passed right over this spot.
There was a bedroom here, bathroom right here.
When it passes, the eye wall attacks everything in its path. But the weirdest thing about a hurricane is this. Right next to this violence, in the middle of the storm, there isn't fury, there's quiet. The eye, blue skies as much as 60 miles, 100 kilometers wide. The rotation of the hurricane causes the air from the eye to push outwards. This is the same force that pushes you out towards the edge of a merry-go-round. It counteracts the air coming in from the rest of the storm. Air from above fills the gap, making it drier and calmer. But there's no way out. You're surrounded. The opposite side of the eye wall is on its way. It's like a 1-2 punch. The back eye wall hits suddenly with maximum fury. Structures that are weakened on the way in can be knocked down on the way out. The result? It took some survivors 3 days to dig out a means of escape. There wasn't much still standing when Hurricane Andrew left town. 99% of all the mobile homes here were destroyed. 11 years later, there's still nothing. Andrew's winds didn't only hit houses. Across southern Florida, boats were thrown up onto the shore and planes smashed. Andrew gusted to 200 miles, that's over 320 kilometers per hour. This is about 50 miles or 80 kilometers an hour, not a hurricane yet. This is Category 1, a baby as hurricanes go. Category 2 winds will blow you down the street. Do you want to know what Category 3 is actually like? It's not just enough to blow you off your feet and down the road. It's enough to make you fly. They train skydivers here. The effects look like weightlessness. It seems graceful, but hurricane winds can reach 1.5 times this speed. In the open, with no protection, that's not graceful. It's terrifying. When winds of this kind of speed occur between tall buildings, it's actually possible for this to happen, for the wind to knock people right off their feet. But wind is only the first of the hurricane's devastating weapons. If we could predict hurricanes exactly, it would be easier to prepare for them. We don't usually know just where they're going, or how hard the wind will blow. This is the National Hurricane Center, where they try to answer these questions. Only a third of Atlantic hurricanes hit land at all, but it's crucial to evacuate people before they do. For 5 long days, scientists and forecasters struggled to predict where Andrew was going next. As Andrew approached Florida, they ordered more than 2 million people to leave. It may cost millions of dollars, but it can cost lives if they don't. Modern satellite and radar technology have made prediction better, but it still isn't perfect. They're usually out by 100 miles or 160 kilometers. The path of a hurricane is determined by all sorts of complex factors, to do with the storm itself, but also with the atmosphere around it. That makes hurricanes hard to tie down. Enter the hurricane hunters. As soon as Andrew was spotted, they scrambled. There's only one way to find out more about a hurricane, the dangerous way, from the inside. These US government scientists have given us new insights, but the storms stay one step ahead. Their nature is unpredictable. Flying straight into the hurricane, they drop these probes, which go right through the heart of the storm. They transmit information about temperature, wind speed, humidity. They use this data to gauge the path of the hurricane, called its track. They hope to predict where it's heading and how strong it is. 3 days before Andrew hit land, it was only a tropical storm. Later flights revealed that Andrew was getting more violent. The scientists needed to know how violent and how quickly. But as Andrew got close to the coast, the Florida hurricane hunters had to stop flying. In weather like this, it was just too dangerous to take off and land. These storms dominate the oceans that spawn them, yet they still manage to be tricky and elusive. Only some of them emerge and hit land, but that's when the destruction really starts. Typhoon Faye from 1995 shows how these storms can use waves as a battering ram. Faye used them to sink more than 70 ships. Busan Harbor in Korea isn't a good place to be when a typhoon hits. These massive freighters were carefully secured. It wasn't good enough. This ship was torn loose and headed for the rocks. Crew members could only cling to their vessel. Some of them didn't make it. Why does a hurricane cause this kind of damage? The force of friction between air and sea whips up these gigantic waves. Waves do massively more damage than wind moving at the same speed. Water carries almost 1,000 times more energy than air. After wind and waves, the third weapon in the hurricane's arsenal is rain. Look at what Hurricane Mitch did when it deluged Central America in 1998. The water it had picked up as it crossed the sea rained back down. Rain's a crafty customer. Hour after hour of it builds up to one of the most damaging forces on Earth. The water in a hurricane is propelled by powerful winds. It can worm its way in through every crack and crevice. But rain doesn't just wreck buildings. Hurricane Mitch spent nearly a week over Honduras and Nicaragua. 35 inches, nearly a metre of rain fell on the area. Mitch travelled slowly, pretty much at walking pace, and that's what made its rainfall so destructive: prolonged saturation. Overwhelmed by this amount of water, rivers broke their banks and massive flooding occurred. Buildings on steep slopes became vulnerable as mud began to flow downhill. People in the valleys were in even greater peril. The streets of the capital became rivers. Buildings were washed away completely. The crater of the Las Casitas volcano filled with rainwater from Hurricane Mitch. When this spilled over, a river of mud, rocks and boulders flowed onto the town below. But rain isn't the worst a hurricane can do. It has one more weapon up its sleeve that is truly terrifying. It's more deadly than wind, waves or rain. This is called storm surge. The wind of the hurricane pushes the water in front of it towards the coastline, raising the level of the sea. A liquid mountain. It looks like a wall of fog coming across the ocean, but this isn't fog. It's a mass of water, sometimes as high as a house, which crunches into the shoreline. Storm surge doesn't just strike with one blow, it's a continuous assault. With each new wave, the water rises higher and travels further inland. But that's not all. They cause impact destruction too. All hurricanes that reach land produce a storm surge. This is Hurricane Camille. It smashed into Mississippi in 1969. This is Hurricane Gordon in Mexico in 2000. There's one place where storm surge hits hardest. Bangladesh has some of the lowest lying land on Earth, and it's one of the most crowded countries. It lies at the head of the Bay of Bengal. It's one of the most dangerous ocean basins in the world for storm surge. The shape of the coast here magnifies the effects of the surge by concentrating it into a smaller area. Tropical Cyclone 2B in 1991 isn't going to be forgotten easily. From the moment it started to form, the forecasters knew it was going to be a big one. It took a week to grow to its maximum power, Category 5, moving ever north. Storm 2B filled the Bay of Bengal. When the bay rose 25 feet, 8 meters, the surge left populated islands totally submerged for 8 hours or more. 120,000 people lived on the island of Kutub Dia. 30,000 were killed. When 2B's storm surge hit Chittagong on mainland Bangladesh, almost 150,000 people were killed and 10 million were displaced. Storm surge at its most deadly. All this mayhem and devastated lives. All a result of warm seawater. Meet Hurricane George, which dominated the Caribbean for 11 days in September 1998. George's story shows how hurricanes live and die. All hurricanes start over the sea. They harvest their energy from warm water. When they hit land and they're starved of that heat, they start to diminish. But George was an endurance champion. It began to dissolve as it passed over the islands of Puerto Rico and Hispaniola. When it hit land, as we can see from its track, the storm lost intensity. But each time, George made it back to water, where its energy was restored. The sea is where hurricanes feed. Land means starvation. How does the energy get from the water into the air? The best way to understand is to build your own hurricane. Well, a small one anyway. The ring of water is the sea. Above it, a fan can push the air up to hurricane force winds. At gale force, waves appear. As they break, spray shoots up into the air above. When the water turns into spray, it transfers more of its heat to the air. The heat powers the winds of the hurricane. Look what happens when we hit hurricane speed. The water's full of air, the air's full of water. The boundary between them has almost disappeared. A typical hurricane produces the same power as all the power stations on Earth. When a hurricane moves over a continent, it's on its way out. The power source is switched off. The hurricane begins to die. George only stopped being a hurricane as it moved deep into the American South. As hurricanes die, they pass back through the stages of their growth, through tropical storm to milder tropical depression, until at last they dissolve entirely. During a hurricane's life, it does more than just wreak havoc. These killer storms actually have one positive characteristic. Hurricanes almost always move away from the equator, and this helps cool down the tropics. After a hurricane has passed over, it leaves the sea several degrees colder. They move the heat they pick up from the water towards the cooler polar regions. This helps to reduce the heat difference between hot and cold parts of the world. Hurricanes are like a form of global air conditioning. And that means they aren't going away. We have to learn to deal with them, and we can. This is the southern Pacific Ocean, where Cyclone Zoe met the island of Tikopia at the very start of 2003. It shows us how people can adapt to living with hurricanes. Cyclone Zoe had some of the fastest wind speeds ever observed in the Southwest Pacific, at 211 miles or 340 kilometers an hour. But when Zoe hit Tikopia, nobody was killed. On Tikopia, they've faced the dangers of cyclones for centuries. They've learned their own ways to survive. There are only about 1,500 people on Tikopia. Using paths their ancestors wore down in previous emergencies, they took to the caves in the high ground. The first outsider to land after the storm took these images of them emerging. But what does the experience of a remote island mean to the rest of the world? This scientist is studying the effects of hurricanes on the swamplands of Louisiana in the deep south of the USA. He's trying to find out how nature copes with hurricanes. The best way to do it is from the air. Hurricane Lily hit in 2002. Before they built New Orleans, the whole of the Mississippi Delta looked like this. Vast wetlands, green and lush. And right in the path of hurricanes. Hurricanes wreak havoc with buildings and cities. For hundreds of years, these wetlands have also absorbed the wrath of the hurricanes. But they don't get totally destroyed, just rearranged. Look at these finger-shaped channels. They didn't used to be there. Remember what Hurricane Andrew did to Miami? This is nature's equivalent of streaky wind pattern. Super strong gusts can actually push the marsh aside. Hurricane Lily even turned the surface layer over. The storm surge floated this whole mat like a boat, speeding it across the marsh. When it hit an object, it flipped over. Under this mud, there's grass. The wind can compress the ground in an accordion effect, literally pleating the marsh. But the wetlands survive. They can absorb hurricanes and even use them for renewal. Nature usually copes with hurricane attack. But 11 of the world's 15 biggest cities lie near the coast. Millions of people live within reach of hurricanes. We can't all escape to caves in the hills, but the next best thing is a hurricane-proof house. And where hurricanes are a major danger, people are building for the worst. What can wind actually do to a home? Fortunately, the people who lived here had taken shelter elsewhere. With a mobile home, the weakest link is the foundations. The home is only tethered to the ground. Break the link, and this is a result. The wind can rip solid buildings to pieces. This cameraman had a lucky escape. The wind has taken the roof off, and it could bring the whole building down. Hurricanes use anything they can pick up to do their dirty work. This corrugated iron is embedded in a tree. And look what this plank did to this house. Think about what that could do to the human body. This team of engineers are playing at hurricanes. The test projectile is accelerated to hurricane speed. This is typical roofing material. Now let's try that again. This is specially designed hurricane roofing, a worthwhile investment in hurricane country. team are deconstructing a house almost like storms do, but they're using a crane. The tests will help them build a better hurricane-proof home. Special ridged nails can withstand over twice as much pressure as an ordinary nail. Waterproofing is tested with mammoth fans. When the wind hits a house, it travels over the roof and its speed increases. It tries to lift the roof right off. Just an open window can cause disaster. Many people tape up windows, but it doesn't necessarily help when a hurricane comes round. Impact-resistant glass can keep debris out, even when it's broken. It's two pieces of glass with a piece of plastic sandwiched in between. You need protection in hurricane country. This is New Orleans, USA. Like many of the world's major cities, it lies near the coast, in danger of hurricanes. This scientist believes it's a disaster waiting to happen. If a Category 4 was to head straight for New Orleans, he believes it would be a catastrophe. October 2002, Hurricane Lily was approaching Louisiana. It was a Category 4. It looked like the catastrophe was about to happen. New Orleans isn't just in the path of hurricanes. It's surrounded by water, some of it as much as 5 feet, nearly 2 meters below sea level. New Orleans is trapped between the river and the lake. These are levees, giant dams, part of the flood defense system that surrounds the city. Here, houses lie only feet from the water. It's even possible the system could channel a hurricane storm surge right into the city. New Orleans is also ringed by chemical and oil processing plants. Scientists don't know what would happen to them if a hurricane hit hard. It's possible that the streets could flow with poisonous chemicals and gasoline. Worst of all, this exit could be blocked. The causeways are one of the main escape routes from the city. Calculations show a Category 5 storm surge could be around 6 feet, 2 meters higher than road level. New Orleans is a disaster waiting to happen. So why didn't it happen in 2002 with Hurricane Lily? There's one amazing theory: that the best way of protecting against hurricanes is more hurricanes. Here's what happens when one hurricane follows immediately in the track of another. The blue shows where the first hurricane sucked up heat from the ocean, leaving cool water behind. There's nothing for the next hurricane to feed on. Some scientists speculate this might explain what happened in 2002 near New Orleans. A dying Hurricane Isidore crossed the Gulf of Mexico. Lily was close behind, a vicious Category 4. But instead of growing over warm sea, Lily shrank, suddenly, right at the coast. Isidore could just have made the difference. Lily only hit with the force of a Category 1. It was a lucky escape. It's not just New Orleans that's in danger. In the last few decades, there's been massive development on many of the world's coastlines. This is Galveston, Texas, 100 years ago. The worst hurricane disaster in US history, around 8,000 killed. Thousands more people live on the coast today. But the stakes could be getting higher still. Not only are there more cities for hurricanes to destroy, but there may also be more hurricanes. Many scientists believe global temperatures are rising. With more heat in the atmosphere, there could be more hurricanes. They may be more severe too. Hurricanes could rule the 21st century. Scientists are trying to find out if hurricanes are getting worse, and they're looking in an unusual place. There are few reliable records of hurricane strength from before 1900. In terms of climate change, that just isn't long enough to know if things are getting worse. But there's one amazing archive of weather information, and this scientist is on his way to consult it. This forest is in Louisiana, USA, the heart of hurricane country, and it may hold the key. It's well inland, but it wears the scars of its long-running battles with the wind. These are called tip-ups, trees that have been blown right over with their root systems exposed. Their direction of fall tells us they were probably victims of the 2002 hurricane season. This is a tree core. Scientists drill right through the center of the trunk, taking a sample of every tree ring. They can examine what happened to the tree every year of its life. Trees don't forget. Some of them have been here since before Columbus first came to America. Even if a tree only loses its leaves to a hurricane, it records the trauma in its growth pattern. This piece of wood holds the history of this region's hurricanes within it. They hope they can use it to reconstruct how many hurricanes have been through here and how severe they were, year on year, for over a century. Tree cores may help show if hurricanes are increasing long-term. This could have global implications. Narrower or missing rings can indicate hurricane damage. If global warming continues, the danger from hurricanes may well get worse. Some scientists think we should fight back. Instead of defending ourselves against hurricanes, we should try to stop them in their tracks by manipulating the weather itself. This has never been done successfully. Scientists are trying to hit the storm where it hurts. This team from MIT in Boston have built an artificial hurricane to study how it draws energy from the sea. Their strategy is to block the storm where it feeds. They plan to spread a layer of oil only one molecule thick over the surface of the ocean. They believe it'll stop the hurricane drawing in heat from the sea and switch it off. Many scientists are skeptical about whether this can be made to work. Another approach uses these amazing absorbent granules. The researchers are trying to take the moisture directly out of the They intend to use aircraft to scatter a cloud of granules into a hurricane. The granules are designed to suck in moisture as they fall through the cloud. The team target the hurricane's weakest side. If they can remove it, they hope the distinctive spinning motion will break up. It's like soaking up the storm with blotting paper. While others are skeptical, they believe the signs are promising. For now, we can only admire the majesty of hurricanes. They're the biggest storms on Earth, crisscrossing the ocean like it's their swimming pool. These giants help control the temperatures across the whole globe. But they threaten coastal cities, even whole countries, with death and destruction. We can't stop these storms, and we don't even know enough to fully understand or predict them. They make us look insignificant. Hurricanes are one storm that's built for destruction.